Hi, and welcome to the second of 3 videos for section 10.5. In video 1, we saw how to do inverses of a 2x2 matrix. Nice little formula, 1 over the determinant, switch some things around, put negative signs, do the calculations, not too bad. If we have an n by n matrix bigger than 2x2, so finding the inverse of an n by n matrix, we do the following. We write a n by 2n matrix with the original on the left half and the identity matrix on the right, or the right half, I guess I should say. Second, using my elementary row operations, well, some of them I should say, using row operations, I'm going to convert the left matrix to the identity matrix. Whoops, identity matrix. And once we've done that, the new matrix on the right is the inverse matrix. So actually pretty neat that somebody figured this out, that if you do these processes, it'll generate the inverse matrix. Now, I said we can do some of our row operations, but we can't do all of them. Why? When we were solving systems, so let's say we had like 3 variables, 3 equations, 3 unknowns. We could switch the rows around. It didn't really matter because it was a system. The inverses are not a system. It's a specified matrix, so you no longer can just switch rows if you want. You have to leave them as they are and generate the ones along the diagonal using the other operations at your disposal. So let's look at an example. So actually, I'm gonna erase this so that I have the whole board to use. Just want to make sure we have the space so I'm not starting on the right and ending up over on the left here. So let's, as in our example, let's find the inverse of the following. A, which is 1, -2, -4, 2, -3, -6, -3, 6, 15. Okay, so the first thing we're going to do to find the inverse, I'm going to rewrite this guy. 1, -2, -4, 2, -3, -6, -3, 6, 15. I'm going to put a dotted line or dashed line vertically on the right side of that. And now I'm going to put the identity matrix on this side. 1, 0, 0, 0, 1, 0, 0, 0, 1. And then close in my matrix. So just as when I was doing reduced row echelon form, basically, I got what? I wanted 1s on the diagonal, 0s in the lower corner, 0s in the upper corner. I want to do the same thing here. And if you want to hit pause and try it, see how far you get, see if you get to the end, that's fine. And again, I want to point out that in the previous videos when I was doing row echelon form, if you guys look at the comments, one of the viewers noticed that, unfortunately, when I went from the one video into the next video and I used the same system, I had a different matrice. And I apologize for that because there is no necessarily right or wrong way to do these depending what steps you're taking. You may end up with different lines at different points. At the end, if you're doing a reduced row echelon form, you should end up with the same numbers. But the one matrix I had at the end of the one video, and then I started and said, okay, here's where we ended last time, they were actually different. So I apologize for that. Hopefully I didn't cause confusion there. But we'll go through here. Like I said, if you want to hit pause and try to get this left side to look like the identity matrix, and whatever ends up on the right, that's your inverse. So for here, I'm going to work with the first row to begin with. 1, -2, -4, 1, 0, 0. I want a 0 in this position, so I'm going to do row 1 times -2 plus row 2 gives me a new row 2. So if I do -2 times 1, that's -2 plus 2 is 0. 4 minus 3, 1. Positive 8 minus 6 is 2. And keep going all the way. -2 plus 0 is -2. 0 plus 1 is 1. 0 plus 0 is 0. So that would be your first row if you multiplied that guy, multiplied to get a 0 there. Now I want to get a 0 in the lower corner here. So I'm going to multiply everything by 3. 3 times 1 is 3, minus 3 is 0. -6 plus 6 is 0. Wow, they were nice to us here. -12 plus 15 is 3. 3 plus 0 is 3. 0 plus 0 is 0. 0 plus 1 is 1. So your last row should be 0, 0, 3, 3, 0, 1. All right, now that we have that, I have the 2 zeros here. That worked nicely for us, but I need a 1 down here. So what can I do? Well, I can divide row 3 by 3. So if I do that, so let's come up over here. If I divide row 3 by 3, I get what? 0, 0, 1. 1, 0, and 1/3. I know, fractions, you'll be okay. So, with that being the case now, we'll leave the rest. So 0, 1, 2, -2, 1, 0, and 1, -2, -4, 1, 0, 0. So now, just as before with reduced row echelon form, I want to work from row 3 and work my way up. So I want to get a 0 here where this 2 is. So I'm going to do what? I'm going to do row 3 times -2 plus row 2 gives me a new row 2. So 0, 0, 1, 1, 0, 1/3. So if I multiply this row by -2, 0 plus 0, 0. Remember, we don't want numbers getting put back in here. For some reason, you end up with a number here, something's off. 0 plus 1, 1. -2 plus 2, 0. -2 minus 2, -4. 0 plus 1, 1. -2 times 1/3, -2/3, plus 0 is -2/3. Now I want to get a 0 up here over this one, which means I need to multiply by a +4. So row 3 times 4 plus row 1 gives me a new row 1. So multiply that by 4. 0 plus 1, 1. 0 plus -2, -2. 4 minus 4, 0. 4 plus 1, 5. 0 plus 0, 0. 4/3 plus 0, 4/3. All right, now all that's left is to get a 0 here, so I need to do what? Row 2 times positive 2 plus row 1 gives me a new row 1. So leave row 2 and 3 alone. So negative 4, 1, negative 2/3, 0, 0, 1, 1, 0, 1/3. The only thing I'm changing is row 1, multiplying row 2 by 2. So 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, minus 2 is 0. 0 plus 0, 0. Negative 8 plus 5, negative 3. 2 plus 0 is 2. 2 times negative 2/3 is negative 4/3. Negative 4/3 plus 4/3 is 0. So now I'm basically done. I have the identity matrix on the left side, which means A inverse is equal to whatever's on the right. Negative 3, 2, 0, negative 4, 1, negative 2/3, 1, 0, positive 1/3. And that's it. That's how we find the matrix of an n by n matrix, the inverse of an n by n matrix. So just a note here. So note, if you cannot convert the left side, to an identity matrix, there is no inverse. So what this means really is that one row is all zeros. So if you're doing these operations and you get 0, 0, 0 in one of the rows, it means this thing has no inverse. So that's it. That's the end of video 2. That's finding inverses of n by n matrices. Come on back and we're going to look at how we can use inverse matrices to solve matrix equations.